Alright, let's go through the review key really fast. A solute is whatever is being dissolved. Usually it's a solid like sugar, but you can also dissolve alcohol in water or a gas in a water or anything else like that. So a solute is what is being dissolved. Solvent is what you are dissolving it into. So in the case of Kool-Aid, you're dissolving the solute, sugar, into the solvent, water. A solution is any time you have a solute that is dissolved in a solvent. We measure that in concentration. A saturated solution means that no additional solute can be dissolved at that temperature. Unsaturated means that you could add more at that temperature. Supersaturated means that you've actually got more solute dissolved than would normally be allowed because you've heated it up and slowly cooled it back. An acid is something that donates hydrogen ions. It's really low on the pH scale, less than 7. Examples would be hydrochloric acid, citric acid, vinegar, etc. A base is something that donates hydroxide, OH negative, ions. It's high on the pH scale, greater than 7. 7 is perfectly neutral, which would be water. pH is how we measure how many hydrogen ions are in that solution. It measures the strength of an acid or a base. Low pH means an acid, high pH means a base. Neutralization means that you've mixed an acid and a base together to reach a neutral pH of 7 that creates water and salt as byproducts. Next, let's talk about the different equations. Parts per million, you divide the solute mass by the combined mass of both the solute and the solvent, and then you multiply that by a million. So, if I had 123 grams of sugar and 577 grams of water, I take 123 divided by the total mass of sugar and water, so 123 divided by 700, that gives me 0.1757. Multiply that by a million, I get 175,714 parts per million. So that would be a very, very large solution if you measured it in those units. Not very efficient to measure it in that unit. Next one, percent concentration. You can either do weight over weight or volume over volume. So an example would be if I took volume over volume. I took 30 milliliters of ethanol and dissolved it in 170 milliliters of water. That would give me a 17.6% solution. We like that number. It's nice, it's even, it doesn't have a lot of decimal places, it doesn't have a ton of digits like in parts per million. Milligrams per liter, remember that's usually how we measure things that are medical, like your blood sugar. So if I had 1 gram of sugar in 40 milliliters of water, first I have to convert grams to milligrams. So 1 gram is 1,000 milligrams. Then I have to convert milliliters to liters. So 40 milliliters is 0.40 liters. Do the math there. That's 25 milligrams in every liter of your blood, or of water, for example. How do you change a saturated solution into unsaturated? A couple different ways. You can either add more solvent, more water, then it would definitely become unsaturated. That would be like watering down your Kool-Aid or your lemonade. Or you could increase the temperature. If you look at our solubility graphs over here, at increased temperature, usually you could dissolve more. So if I had, for example, sodium chlorate here, and I had 120 grams dissolved at 30 degrees, that would be a saturated solution. But if I heat it up, it's no longer saturated. That same 120 grams is not going to saturate that solution anymore. Opposite is true. If you're trying to make it into a saturated solution, you either have to add more solute or lower the temperature. Acids give off H+ ions. We already talked about that. Examples would be hydrochloric acid, HCl, H2SO4, or HF, which is hydrofluoric acid, that really, really bad one. You know that these are acids because they have an H, but not an OH group to donate. Other examples of bases would be NaOH, has that nice OH group to donate, KOH, or CaOH2. All of those have a very clear and obvious OH group to donate. Acids and bases we'll cover on the back some more. The solubility graph we already talked about a little bit. The unit is grams per 100 grams of water, and you can see that right there on the y-axis.